So if everyone would be so kind as to, probably the best place to do this is on the bottom of page 82 where you've got a bunch of blank space. It's not new. It's just the exponent laws that you already know taken to one more step. And it's what you need to be able to do if you are going to do page 83 and 84, which is what I'm going to ask you to do today. Okay? So let's start with something that you indeed already know. What is x to the 10th divided by x to the 8th? X to the 2. Why? When you're thinking, this is your thinking, that's x to the 10 minus 8, right? Because that leads you to your next thought. I don't remember the law, Mr. Myers. It's 10 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 8 x's, 1, 2, 3, 4, 5, 6, 7, 8. And then 8 of them cancel, right? That's why 10 minus 8 works. Yeah? All right. Wait a second. Let me get my pen light back. So all of you already know that, yeah?
What happens if one's a negative, one's a positive?
I'm getting to that, Ethan. What would you do if you had this question, which isn't an exponent question? 24 over 4. What would that be? 24. That's 24 divided by 4, which is 6. Excellent. Everybody cool with that? So everybody in the room can do 24 divided by 4, yes? And everybody in the room can do x to the 10th divided by x to the 8th, yes? So what then is 24x to the 10th divided by 4x to the 8th? Riley. 6x squared. See how you already knew how to do this much more difficult exponent question. Because you already knew that and you already knew that. And if it works once in math, does it not always work in math? Yes. Now, Ethan asked a question that I'm going to cover in one moment, because his question is 2 steps away from where we are right now. The next logical question to ask is, what would you do if you were faced with this? 8 over 12 in a math class. You would divide that. What would you get? A decimal. So you would not want to divide it because you could not do that in your head. It's not a lowest common denominator because there's nothing common. You'd simplify it, right? You'd start with dividing by 2, which would get you 4/6. And then what would you do? You would do it again, and you would get 2/3, correct? Okay. So what then does that mean is the answer to this? 8x to the 10th over 12x to the 8th. 2/3 x squared. Now, would you write it like that? No, because what is the true denominator under x? 1, because x is really a numerator, isn't it? And then when we multiply fractions, we get 2. The x is part of the numerator, and the 3 times 1, the 3 goes there. Again, nothing new, stuff you already know from the old days of fractions, yes? Everybody cool? Okay, now the next logical step from there is, what if it was 12 over 8? What would that be? If 8 over 12 was 2 over 3, what's 12 over 8? 3 over 2. So what then is the answer to this question when I change the 12 and the 8? 3x squared over 2. All that built on the knowledge that I gave you 2 days ago and the knowledge that Mrs. Bag Crumble gave you 10 years ago. Yes? Everybody good? All right. Now we come to Ethan's question. And this is the last thing I'm going to show you before I let you free today to attempt to put all this together. 8x to the 6th over, well, let's keep with 12. 12x to the 8th. You already know what the 8 and the 12 are going to be. What is that going to be? 2 over 3. And what is the x's going to be? -2. What is a base here? 2/3 x or 2/3 x? Which of them is the base? 2/3 x. X is the base, yes? Because x has its exponent. What isn't allowed when you have an exponent? So where does that negative have to go so it's positive? To the denominator. So it becomes 2 over 3x squared. Exact same thing as over here, except because the numerator, the x had a negative, it had to be reciprocated. Is everybody good? All right, now listen. Finish by the end of this block. I expect pages 81 to 84 done. Now, when you look at 83 and 84, and Riley, I see your hand, I'll be right with you. Pardon me? Oh, okay. You notice on 83 and 84, there are some circled questions, yes? They are circled because those are what I deem to be the best questions to show you as much as you can about exponent laws on here. So what this means is if you do these circled questions and you get them all right, you have a fairly passable knowledge of exponents, right? Good enough to get you through. But like everything, if you want to be better, you practice more. So there is a million more questions, not a million, like 20, more questions that you can do should you need to. Should you feel like doing extra practice. Now, I know that very few of you, if any of you, are going to feel like doing extra practice. A bunch of you are going to get a bunch of these circled ones wrong and then not practice anymore either. But I cannot control what you do outside of this room. So that is on you. Okay? All right. 81 to 84. Now, 81 and 82 should already be done. But apparently I was not as good a communicator as I think I am on Thursday and Friday to my other block. So I'm going to give you guys the same deal they got, whether you're done or not. If you're not done 81 and 82, you start on them now. I'm going to show you the right answers to them in a little while. I'm going to put it up behind me. You can look it over, ask me questions. Okay? Then, depending on how the day goes, I might get to these questions, and I might not. If I don't, I'll add these questions, keys, to this recording. And you can check it tonight. Okay? Everybody good? All right. 81 to 84. You can talk to each other. You can ask me anything you want. You can use your notes. It's all good. Go. Oh, and at some point today, we'll play Gummy Bears. Sorry, what? Not on my, not right now, and not on your first test, but on a final, I would probably have to take something away. Any questions about 1 through 12?
Why is it 1 over 83?
Because 2 plus -5 is a to the negative 3. And you're not allowed to have negative exponents.
Okay.
What does that say? How much did I stress when we were learning this that negative exponents cannot exist? Exactly. That's why I give you practice. So when I give you a quiz or a test on these, you will not make that same mistake. Some of you will still make that same mistake, but that's no big deal. That's why I give you quizzes as well. Eventually, after enough practice, hopefully you will remember that negative exponents cannot exist. And you have a mathematical tool for fixing them. Mr. Mars, you're a mathematical tool.
Okay, so then what do you have in the rewriting on 6?
On 6 is 1 over x to the 3.
No, I meant like the little right beside it. Like,
2 minus 5 equals negative 3. Because 2 plus 2, when you're dividing, you subtract your exponents. So 2 minus 5 is negative 3.
Move on, it should just be A3 because 2 minus negative 5 is
But you're not doing subtraction. It's multiplying.
right.
Everyone is good up to 12.
yeah. No.
All right. It is recorded. You can add, you can go back and check it later. There is 13 to 28. Please check them. If you need to ask, then by all means ask. Josh.
For the first one, writing 3 over 5 in brackets, and then on the outside, writing 12 as the exponent is already
I would accept that, except please remember that your goal is to show me you know as many exponent laws as possible, right? So you would want to go one further.
Mr. Myers, did you flip 16 because it was a negative? Like the exponents were negative? Is that what
Yes. So 16, there's two ways you can do 16. One, you could multiply this in at the very beginning, which would get you c to the negative 8 over d to the negative 8, which is what I did, yes? The other thing you could have done, and I'll write that in red, as soon as you see a negative exponent, you can flip the whole base and change this positive. So the other thing you could have done was said, oh, negative exponent. That means the entire base flips over and the exponent becomes positive. And then 4 times 2, you would still get D8 over C8. You would still get the same answer. Either way works. The reason I show you this way, and don't write down what I'm about to do, if you get a question like this, Tasha, c to the negative 8 over d squared all to the negative 2. If you don't really know what you're doing, and you see that negative and say, okay, I get to flip, a bunch of you will make this mistake. You'll go d2c, and you'll change this 8 to a positive 8, and you'll change that negative 2 to a positive 2. That's not allowed. Flipping the fraction only changes the outside exponent. Okay? So that's why I like to show the long way first. How you distribute it in and then move stuff around. Okay? But as you can see, they will both give you the same answer. Anything else down to 28? 17. Okay. If that wasn't there, then what would the answer be? What's the base? 2b, because there's brackets. So the 2 gets squared and the b gets squared. Okay? If that wasn't there, then the denominator would be 5 squared, 25, and c squared, c squared. But since they're both there, we have to leave them both there. It just goes to everything inside. So that 2 has to go to the 2, the b, the 5, and the c. That's 4b squared.
Oh,
That's a b.
sorry.
That's okay.
That's probably.
The next one that screws kids up most is 20. 20. Because it's not a fraction, right? So they don't know if they can flip it or not. They're not sure. Is everybody okay up to 28? Going, Ethan. 17. That's what I just did. I explained the whole thing to Tasha. Okay. The 2 on the outside, because of these brackets, this means the whole thing is a base. So the whole thing gets 2. So 2 gets squared. There's your 4. B gets squared. There's your b squared. 5 gets squared. There's your 25. C gets squared. There's your c squared. And because 4 and 25 don't simplify, we leave them as 4 and 25. But if it was 5 and 25, then we would simplify it to 1/5. Okay? Anybody else?
21, why do you put it into a fraction?
Because when you multiply this 3 to -1, you get y to the -3.
Yeah.
-3 isn't allowed for an exponent,
Okay.
so just that one has to go down to the denominator because the x has a positive exponent.
Okay.
Good for grapes? Good band. They're from Surrey. Something good happens in Surrey. I went to kindergarten in Surrey, and I skipped grade 1 in Surrey, and I went to 2 months of grade 2 in Surrey, and then I moved out of Surrey. So something good did come out of Surrey. Hey, see what I did there? Huh? All right. I'm just joking. Surrey is awesome. Maybe one of my math videos has gone viral and somebody from Surrey is a fan of mine now, and they hear that, and then maybe they get mad at me. And there is 29 to 35. Please check your work. Ask any questions you may have. Everybody good? Everybody good? Nobody needs to ask about any of those. Cool. Okay.